So the starting point is that we take aerospace grade carbon fibers in a woven pattern and reinforce that with carbon aerogel to produce the electrodes and also the reinforcement for this composite multifunctional material. We have two of these electrodes and separate them using an insulating separator. We can form a small device as shown here, and we can bond these layers using a structural epoxy in a pattern. So we take two of the carbon fiber electrodes and have the separator in between, and then also attach some current collectors to distribute the current throughout the device. We also bond the layers together using the structural epoxy, encapsulate the whole device to prevent moisture ingress and isolate the device, and then infuse some ionic liquid electrolyte. So we've made 12 of these devices, and I can show one of these working using a simple electronics box, which allows us to charge up one of the cells, and when we move to the discharge, we can see that it lights up a small LED. So what we've made is a composite multifunctional structural beam, which represents a component which would be in an aircraft fuselage. So you can see it's quite light as it's a composite part, and within that beam we've integrated 8 of the cells that I showed earlier, 4 in one stack here with the connectors coming out at the end, and another 4 as a stack in the other end. If we press this button, we're connecting an external power supply to charge up the structural stiffener beam. And so this simulates an emergency scenario where, in advance of the aircraft taking off, the beam would have been charged up and supplies a backup supply of energy, such that if there is any power failure and the aircraft needs to force open the doors in an emergency, power can be supplied from the structural composite part. So when releasing the button, it disconnects the power supply, and we can use the structural composite part to drive open and close the door mechanism.